Welcome to Arizona State University's University Academic Success Programs. This video will cover the topic Quadratic Functions.
What are quadratic functions?
Quadratic functions are functions of the form ax square plus bx plus c where a is not equal to 0. In this video, we will be looking at completing the square, sketching the curve of the quadratic function, finding the x and y intercepts, determining the zeros of the quadratic function. Let us look at the learning objectives one by one. Let us begin with completing the square. Completing the square is the method where we express the quadratic function as a whole square. Let us consider an example. Let us say we have a quadratic function 4x square plus 8x plus 7 and we are required to complete the square. Before getting into the problem, let us refresh a few algebraic identities. A plus b whole square equals a square plus 2ab plus b square. Similarly, a minus b whole square equals
A squared minus 2ab plus b squared.
That is right. So, in order to express the quadratic function as a whole square, we can make use of these identities. Consider the quadratic equation 4x square plus 8x plus 7. We first divide the entire equation by the coefficient of x square, which is 4 in this case. Thus, we obtain x square plus 2x plus 7 by 4. Finally, we split the constant such that we express the quadratic function as a whole square.
How do we split constant?
We compare the function with the appropriate algebraic identity. The first term is x square and hence a is equal to x. The second term corresponds to 2ab and we have 2x. This implies b equals 1. The final term should be b square, which is 1. But we have 7 by 4 in this case. So we write 7 by 4 as 1 plus 3 by 4. Now we get x square plus 2x plus 1 plus 3 by 4. You can see that x square plus 2x plus 1 is of the form a square plus 2ab plus b square, and hence the quadratic equation is simplified as x plus 1 whole square plus 3 by 4.
Okay, I understand the procedure.
Excellent. Let us move on to the next concept. Let us see how we can sketch the curve of the quadratic function. The curve of a quadratic function is called a parabola. Let us say we have to sketch the curve of the quadratic function y equals x square. This is the simplest quadratic function. The idea is to determine the points the quadratic function will pass through in the graph. Let us draw a table. Select the y values and determine the corresponding x values. When y equals 0, x square equals 0, this implies x equals 0. Thus, the first point is when y equals 0, x equals 0. Similarly, we have when y equals 1, x equals plus or minus 1. When y equals 4, x equals plus or minus 2. Thus, the points we are required to plot are 0, 0, 1, 1, negative 1, 1, 2, 4 and negative 2, 4. We plot these points on the graph and finally connect these points to get the curve. This leads us to the next concept of x and y intercepts. X-intercepts are points where a function intersects the x-axis, and y-intercepts are the points where the function intersects the y-axis. In order to calculate the x-intercepts, we set y equals 0 and solve the equation for x, since at the points where the curve cuts the x-axis, the value of y would be 0.
To calculate the y-intercept, we set x equals 0 and solve the equation for y, right?
That is right. Let us say we have to determine the x and y intercepts of the function y equals x square plus 5x plus 6. In order to calculate the x-intercept, we set y equals 0 and solve the equation for x. We get x square plus 5x plus 6 equals 0. Expressing the quadratic function as a product of its factors, we get x plus 2 times x plus 3 equals 0. This implies x equals negative 2 and x equals negative 3. Thus, the curve cuts the x-axis at 2 points, namely negative 2, 0 and negative 3, 0. Similarly, to find the y-intercepts, we set x equals 0 and solve the equation for y. We get y equals 0 squared plus 5 times 0 plus 6, which equals 6. Thus, the curve cuts the y-axis at the point 0, 6. In order to determine the zeros of a quadratic function, we follow these steps. We express the quadratic function as a product of its factors. Finally, we equate the individual factors to 0 to obtain the zeros of the quadratic function.
Okay, can we do an example?
Sure, let us consider the following example. Let us say we are required to determine the zeros of the quadratic function x square plus 6x plus 8. The first step is to express the quadratic function as a product of its factors. Thus, we have x square plus 6x plus 8 equals x plus 2 times x plus 4. Finally, we equate the individual factors to 0 to obtain the final answer. We thus obtain x equals negative 2 and x equals negative 4 are the zeros of the quadratic function.
Okay, I think I understand the concept. While completing the square, we express the quadratic function as a whole square by using algebraic identities and splitting the concept. Next, we stretch the curve of the quadratic formula. We make the table where we calculate the x values for given y values and then plot them on the graph. To determine the x-intercepts, we set y equals 0 and solve the equation for x. And to determine the y-intercept, we set x equals 0 and solve the equation for y. To determine the zeros of the quadratic function, we express the quadratic function as all products of its factors and finally equate them to 0.
Perfect!